This is why you need to know about the B-52, an unstoppable force that's been dominating the skies for nearly a century. The Boeing B-52 Stratofortress is a long-range, subsonic, jet-powered strategic bomber developed by Boeing and operated by the US Air Force since the 1950s and NASA from 1959 to 2007. Initially designed for nuclear deterrence during the Cold War, the B-52 has a payload capacity of up to 70,000 pounds and a combat range of approximately 8,800 miles without refueling. Its design evolved from a turboprop to a turbojet engine, and it first flew in 1952, entering service in 1955. Despite the development of more advanced bombers, the B-52 remains in service due to its performance and cost efficiency, participating in multiple conflicts using conventional munitions. Known informally as the Buff, 76 B-52s are in inventory as of 2024, operated by active and reserve forces. The aircraft was initially under the Strategic Air Command, later transferred to the Air Combat Command, and is now part of the Air Force Global Strike Command. After upgrades between 2013 and 2015, the B-52 is expected to remain in service into the 2050s, marking over 100 years of use. The origin of the B-52. In 1945, the Air Materiel Command, AMC, outlined requirements for a new strategic bomber that could operate without relying on foreign bases, carrying a large crew and weapons payload with a specified range and speed. By 1946, Boeing's Model 462, a straight-wing design with 6 turboprop engines, was selected as the winner of the bid, but concerns over its size and performance led to a redesign, producing the smaller Model 464 with 4 engines. General Curtis LeMay later requested a higher cruising speed of 400 miles per hour, prompting further design changes. Boeing then proposed 2 variations: Model 464, 16 for nuclear missions, and Model 464, 17 for general purposes. Due to cost concerns, the USAAF chose the adaptable Model 464, 17. Despite meeting most updated requirements, the XB-52 project was postponed due to concerns over its performance compared to existing bombers like the B-36 Peacemaker. During this period, Boeing continued to refine the design, creating the Model 464, 29, but it still fell short of new requirements for speed and range. The project faced possible cancellation in December 1947, but was saved by Boeing's argument that the design could adapt to technological advancements. By 1948, Boeing was instructed to explore new technologies like aerial refueling, leading to the Model 464, 35 prototype. The final revisions resulted in a bomber with a top speed of 513 miles per hour, a range of 6,909 miles, and a gross weight of 280,000 pounds, including fuel and a 10,000 pound bomb load. The design, the B-52 Stratofortress, shared many technological features with its predecessor, the B-47 Stratojet, including swept wings and podded jet engines, as well as a cabin with ejection systems for the crew. On the B-52D model, pilots and the ECM operator ejected upwards, while lower deck crew ejected downwards. Until the B-52G, the tail gunner had to manually jettison the gun to bail out. In early models, the tail gunner was positioned at the tail of the plane with visual and radar targeting, later moving to the front with radar-only control similar to the B-58 Hustler. Low-altitude flight led to increased structural fatigue, prompting the USAF to launch various repair programs such as the high-stress program in the 1960s and wing and fuselage modifications throughout the decade. Despite improvements, fuel leaks remained an issue across all B-52 variants, necessitating safety enhancements through the Blue Band, hardshell, and quick-clip programs to prevent catastrophic loss. While the B-52's service ceiling is officially 50,000 feet, it typically operates optimally around 43,000 feet due to range considerations when carrying a full payload. A notable incident in 1964 saw a B-52H safely land after losing its vertical stabilizer in severe turbulence. In 2006, The B-52 became one of the first US military aircraft to fly on alternative fuel, using a 50/50th blend of Fischer-Tropsch synthetic fuel and JP-8. By December of that year, a B-52 flew entirely on the synthetic blend, part of a Department of Defense initiative to reduce crude oil reliance. The B-52H was fully certified to use this blend in 2007. The upgrades the B-52 has gone through. A proposed B-52H variant, the EB-52H, aimed to restore the US Air Force's USAF airborne jamming capability, lost after the retirement of the EF-111 Raven. 16 modified B-52Hs were planned for this role, but the program was cancelled in 2005, briefly revived in 2007, and ultimately cut again in 2009. In 2013, the USAF began the Combat Network Communications Technology Connect upgrade across the B-52 fleet to modernize electronics, communications, computing, and avionics. The upgrades include new hardware like computer servers, modems, radios, and data links, enabling in-flight data sharing with ground control through systems like the AN ARC 210 Warrior radio and Link 16. The Connect program costs $1.1 billion and is being gradually implemented, with funding secured for 30 aircraft. Weapons upgrades include the 1760 Internal Weapons Bay Upgrade, IWBU, allowing a 66% increase in weapons payload through a digital interface and rotary launcher. This $313 million upgrade enables carrying 8 JDAM bombs, AGM-158B JASSM-ER cruise missiles, and ADM-160 CMOL-J decoys internally, enhancing precision strike capability and reducing drag, which improves fuel efficiency by 15%. The USAF Research Lab is also exploring defensive laser weapons for the B-52. Additionally, planned upgrades include a new APG-79B4, active electronically scanned array radar, improved communication systems, streamlined nose design, new cockpit displays, new pylons, and deletion of one crew station, culminating in the redesignation of the B-52 as the B-52J. Avionics. To address avionics issues, the B-52 underwent the Jolly Well program, completed in 1964, which improved components of the AN/ASQ-38 bombing, navigational and terrain computers. By 1965, most aircraft were fitted with the Madric upgrade to detect failures in avionics and weapons systems, particularly essential for monitoring AGM-28 Hound Dog missiles. The B-52's electronic countermeasures were enhanced through Rivet Rambler, 1971, and Rivet Ace, 1973. To improve low-altitude operations, the AN/ASQ-151 Electro-Optical Viewing System, EVS, was added to B-52Gs and Hs from 1972 to 1976, providing low-light television, LLTV, and forward-looking infrared FLIR capabilities. In the 1980s, GPS was added to augment navigation, with the IBM AP101 computer as the B-52's main system, also used on the B-1 Lancer and the Space Shuttle. In 2007, the Lightning targeting pod was integrated, significantly enhancing ground attack capabilities by providing laser guidance, high-resolution FLIR, and a CCD camera for target imagery. The Lightning pod is also used on other US aircraft like the FA-18 Hornet, F-16 Fighting Falcon, and AV-8B Harrier II. Armament. Starting in 1971, B-52G and H models gained the capability to carry up to 20 AGM-69 SRAM nuclear missiles. Air-launched cruise missiles, ALCMs, were later fitted, with the AGM-86B selected for use on the B-52. A total of 194 B-52Gs and Hs were modified to carry up to 12 AGM-86S on underwing pylons, and 82 B-52Hs could carry an additional 8 missiles internally. To comply with SALT II treaty requirements, the B-52G received a wing route fairing for visual identification, while all B-52Hs were assumed to have modifications without visual markers. The AGM-129 ACM was introduced in 1990 to replace the AGM-86, but saw limited production. Non-cruise missile B-52Gs received upgrades for conventional bombing, adding the Integrated Conventional Stores Management System, ICSMS, and underwing pylons for larger bombers. 30 B-52Gs were modified to carry up to 12 AGM-84 Harpoon anti-ship missiles, and 12 were fitted for the AGM-142 HAVNAP air-to-ground missile. After the B-52G's retirement in 1994, 4 B-52Gs were urgently modified to carry Harpoon and 4 to carry HAVNAP under the Rapid 8 program. The B-52H underwent the Conventional Enhancement Modification (CEM) program, which added capabilities to carry modern conventional weapons like JDAMs, AGM-154 glide bombs, and AGM-158 JASSM missiles. The CEM also integrated GPS navigation and modernized its FLIR system, with 47 B-52Hs modified by 1996 and an additional 19 by 1999. Around 2010, the B-52 was no longer tasked with carrying B-61 and B-83 nuclear gravity bombs, focusing instead on nuclear cruise missiles and expanding its conventional strike role. By 2019, these bombs were officially removed from the B-52's approved weaponry. Boeing began upgrading the internal rotary launchers to a digital interface, MIL-CD1760, to enable internal carriage of smart bombs previously carried only on wing hardpoints. Although the B-1 Lancer has a larger theoretical payload, the B-52's use of conventional rotary launchers allows it to carry a wider variety of JDAM variants. Future upgrades to the B-52 inventory include the AGM-183A air-launched rapid response (RRW) hypersonic missile and the long-range standoff (LRSO) nuclear cruise missile. Engines. The B-52's 8 engines are paired in pods and suspended by 4 pylons beneath the wings, designed to function as wing fences to prevent stalling. Early models, such as the XB-52 and YB-52 prototypes, used experimental Pratt and Whitney YJ-57 engines, while the B-52A switched to J-57P1W engines with water injection for increased thrust. Subsequent models, B-52B to G, upgraded to various J-57 engines with improved thrust. The B-52H model, introduced in 1961, was equipped with Pratt and Whitney TF-33 turbofans, offering quieter operation and maximum thrust of 17,100 pounds force. Several engine retrofit proposals have been considered to improve range and efficiency. In the 1990s, a proposal to replace the 8 TF-33 engines with 4 Rolls-Royce RB-211 engines was rejected due to cost concerns. However, a 2003 Defense Science Board report disputed this decision, suggesting significant cost savings and environmental benefits from re-engining. In 2020, the USAF requested proposals for a re-engining program, ultimately selecting the Rolls-Royce F-130 to replace the existing engines while retaining the B-52's 8-engine configuration to avoid costly airframe modifications. The new F-130-powered B-52Hs will be redesignated as B-52Js. The B-52 Stratofortress stands as a remarkable testament to engineering excellence, military adaptability, and sheer power. With over 70 years of operational history, it has evolved to meet ever-changing needs, proving its resilience and versatility in every mission it undertakes. From carrying massive payloads of conventional and nuclear armaments to undergoing countless technological upgrades, the B-52 remains a crucial asset in the US Air Force's fleet. Its unmatched range, flexibility, and capacity for future enhancement make it not only a symbol of American air power, but also one of the most enduring and formidable aircraft ever built. As it continues to be modernized, the B-52 will surely remain a formidable force in the skies for decades to come.